personalities there. Carrie has 30 years of experience promoting increased recycling of organics through education, research, and advocacy. Carrie has worked for the US Composting Council for nearly 8 years and is currently the Director of Education and Annual Conference. So please join me in welcoming Carrie, and we'll go ahead and pass it over to you, Carrie. Thank you so much for being with us today.
All right. Well, thanks, Danny. How do I sound?
Sounds nice and clear. Thank you so very much.
You're welcome. Well, welcome everyone. Whether good morning, good afternoon, good night if you're calling from someplace far away. It's a pleasure to be here. As Danny mentioned, I am with the US Composting Council. I do our education programs, also put on our annual conference. More important maybe for today, also, I grew up going to camps. My kids all went to camps. My wife worked as a camp nurse, so we're thoroughly embedded into camp culture and was happy to accept Danny's invitation to present today. So I'm going to be talking about kind of the basics of composting. This is only a 15, 20-minute presentation, so obviously I won't get into very many details, but just hopefully enough to give you some basics and some flavor. And if you're looking for more information, you could always visit our website, compostingcouncil.org. So I'm going to start off with some real basics of what is composting. So taking materials that were once alive are now no longer of use. They're a waste product, and we can recycle them into something new. How does that work? Well, we start off with the basic materials, what we as an industry call the feedstocks. That's the stuff that's going to make up your compost pile. A variety of things that can be composted. Ultimately, anything that was once alive can be composted, but there are some things that are harder than others. So here you have a couple of pictures in the upper left. On the upper left, you see a pile of yard debris that's been collected at a municipal program. Those represent what are frequently referred to in composters as the browns, or the high carbon feedstocks. Leaves, brush, chopped up trees, sawdust, those are all browns. On the far right corner, the bottom right, you see some grass clippings, and grass clippings are a good source of nitrogen for our pile, or otherwise referred to as greens. Anytime you make a compost pile, you typically aim for a ratio of about 3 times as many browns as greens. So if for every 3 shovels, every 3 buckets of leaves, you would have 1 of grass clippings. Middle there, kind of upper right, are some food scraps. Those are the kind of things that might be collected in a cafeteria. In this case, this is from a grocery store. You see some peppers, some oranges, some greens. You also see some plastics. So those are contaminants in our process. Conventional plastics do not break down, and they either have to be screened out or picked out at some point, or you end up with them in your compost. On the bottom left is an example of another kind of very common food feedstock. This is a farm byproduct. In this case, these are onions and peppers from a food processor. Actually, one of the smelliest piles I ever smelled was a pile of rotting onions. But again, can be included in composting and make a good source. Lots of water in any kind of leftover fruits and vegetables, which are good for our compost piles. Some other examples, upper left-hand corner, you see some horses in front of some straw. That represents our manures. Horse bedding, horse manure, chickens, hamsters, goats, whatever, any kind of animal manure other than things that come from dogs or cats or other carnivores are great things to add into our compost piles. Some things like horses tend to have lots of browns already mixed into them. Others tend to be just more pure manure, and so really are a green, a high nitrogen material. Like in the middle there on the bottom is a bucket load of animal parts, actually from a butchery in upstate New York at a local college up there, where they take the leftover meat from their slaughterhouse and add it and compost it. Now if you've taken any classes on home composting or backyard composting, you would have heard to not include meat and dairy in those piles. And that's not because they can't be composted, but because they tend to attract pests. But at a larger scale, at at a commercial composting scale or even a community composting scale, a camp scale, depending on your size, perfectly compostable materials, lots of nitrogen, uh, but have to be handled properly. My upper right corner, the oranges are in a container that was marked for collection from on a street, on a curbside collection program in Southern California, and just brings up the idea that what's one person's food waste is another person's yard waste. And you also reminds me to mention that another myth or another warning you may have heard is to not include citrus in your compost, and that's really a myth. Citrus compost just fine. And then on the bottom right corner, you see a slide that's actually a sign from University of San Francisco in their cafeteria, and they're letting people know what's included in their compost program. In this case, not only the food, but paper cups, napkins, paper boxes, things like that. In other campuses, you might be looking at compostable plastics, cups, cutlery, plates, anything that's certified compostable can be composted, although they usually require hotter. They don't work at a home scale because your home compost piles don't get big enough. At a camp scale, they certainly can work as long as you don't be fooled into buying something that says biodegradable but is not certified. And so you always want to look for the certification. In this country, that would be the BPI certification. Again, if you're looking for more information on that, my contact information is provided. So those are our feedstocks. The next thing we need to break down these feedstocks are the microorganisms. The microorganisms are our workhorse. They're our microherd. They're the things that are actually doing the work for us. And they come with the feedstocks. Everything that you add into your pile will already have microorganisms on there. You could also add microorganisms by recycling some of your old compost back into your next compost pile. Great source of microorganisms already adapted to your situation. These include bacteria. Bacteria are the workhorse of our system. They break down the fats, the sugars, the starches, the proteins, and they produce the heat that a compost pile can generate. But they can't do everything. We also need fungi that can break down lignins and cellulose and things that bacteria can't break into on their own. Very important, especially during the curing process of our compost. And we talk about composting as having two main phases: the hot phase, the active phase, the thermophilic phase. All those things mean the same thing. And then the cooler curing phase, and that's when the fungus can really break down some of the tougher materials. And finally, we have these things that are kind of in the middle, actinomycetes. They're kind of hybrid between bacteria and fungus. You can see on these micrographs there are a chain of individual cells making a long filament. Actinomycetes also are important in breaking down of cellulose and lignin. They also are responsible for the good odors of compost. Sometimes compost has bad odors, sometimes it has pleasant odors, and the pleasant odors would come from these guys, the same organisms that make the smell on a forest floor after a rainstorm, because they're very active in that duff layer of the forest. So we've got feedstocks of microbes. What else do we need? We need oxygen and water, two of the two critical pieces to make the compost pile work. Moisture is important, water is important because microbes need water to live. And the bacteria actually live in water. If you looked at a piece of composting material up close, you would find that the bacteria live in a very thin film of water that surrounds every particle in your compost pile. And so they need water to live as well as for their own life processes. So we want to aim for a pile that's about 50% water. 45 to 60% is a perfectly good range. You can tell if you're in the right range by giving it a squeeze. If that material feels dry, if it doesn't feel like there's water in it, it's dry and it'll be too low. And those microbes, especially the bacteria, will be slowed down. On the other hand, if you can squeeze out more than a couple of drops, you're too wet, and that's going to have other problems, which I'll talk about in a minute. It's also important to know that composting consumes water as it goes, that the microbes are always giving off moisture, just like we give off water vapor in our breath. microbes give off water vapor as they respire, and so over time your pile will dry down unless it's getting rained on or you're adding water to it. So that's water. The other thing that oxygen that the pile needs is aeration. Aeration provides oxygen. Oxygen is critical to your pile because the microbes will be much more efficient in a high oxygen environment. So our air that we breathe is 21% oxygen. As it enters the pile, it gets used up. It drops down to 18, 15, 10, 5. As long as you're up in that range, you're doing fine. Once it drops down into the 1% range, and you wouldn't know this unless you have an oxygen meter, but you would also know it because of odors. So when the microbes don't have enough oxygen, they switch to anaerobic respiration, and that causes odors. And so most odors are caused because there's not enough oxygen getting into the pile. We control oxygen, we call aeration, primarily by the feedstocks. That is, if you have chunks of material, sticks, branches, things that are going to hold up the pile and create pore space, that's going to allow air to penetrate. If it's compacted, then the air can't get in. And if water is filling up all those pores, if you're over that 60, 65% range and all your pile is sopping wet, air can't get in. And so most compost piles are aerated just by diffusion. And that's the simple process of warm air rising by convection. And that as that air rises, that's going to create a very slight vacuum, which will then draw cooler air in. Some composters go to a next step. Instead of relying on this convective current, they will actually blow air. And they can blow air in a positive mode, which is here you see a fan blowing cool air into the middle of a pile, which then comes out as warm air. Or you can do it in reverse. You can actually pull air into the pile and then suck it out through the fan and that the advantage of that is that you can then treat that stinky air. The disadvantage is that it costs more money. It's harder to run a fan. There's more wear and tear on a fan. So, but the advantage again is that you can control odors even more. And so now we've added the 4 critical ingredients to our pile: the feedstocks, the microbes, the oxygen, and the water. What do we get out? Well, we get out compost for sure. That's what we're doing here. And as we're doing that, the microbes are giving off water vapor, as I mentioned. They're giving off carbon dioxide, just as we give off carbon dioxide in our breath. Microbes give off carbon dioxide and heat that is microbes every time they break down and respire. They give off a little bit of heat. The compost being a good insulator, that heat will build up in the pile until it reaches some kind of equilibrium. And heat is good because all these things happen faster at higher temperatures. So we like a hot compost pile. And finally, we might get odors out of our pile. Odors are always part of the composting process. There is no way to not have odors in the pile. However, we can work hard and we can be successful at keeping the odors in the pile and not having them create any nuisances. And that's part of the art and science of composting, is knowing how to do that. So one of the basic realities is that regardless of scale, whatever scale you're working at in your composting, these 4 critical features, the feedstocks, the microbes, the air, and the water, have to be maintained and have to be attended to. And just a few examples of some different scales of composting. The home scale on the left here, you see a nice 3-bin system, typical for a kind of aggressive home composter would have something like that. On the right, though, is a simple pile, and that's a perfectly acceptable way to make a compost pile, is to not have it contained if you've got the room to do it, if you're not worried about keeping out pests and things like that. And this is a farmer in Oregon who's taking some food processing, I think farmers market residuals. Some more advanced systems on the left is kind of a 3-bin system on steroids. This is for a horse farm, and he's actually blowing air through. You can see those white pipes on the left there. So those are allowing air to blow in through the bottoms of these piles. Although it could be, you get a very similar system without the aeration, just using the natural convective airflow. On the right are what would be called the InVessel Systems. These particular ones are the Earth Tub from Green Mountain Technologies, situated behind I believe that's outside of a hospital, and that they're composting their food scraps from their cafeteria. Larger scale systems, you've got on the left here a windrow system. Those are long piles of compost for composting just green waste and yard waste from a landscaper. On the right are some another kind of in-vessel system. Those are kind of like silage bags where the compostable materials are put inside the bag, and the bag has air control in it, and that way you're preventing odors in a urban environment. And just for fun, two of the largest facilities in the country, both located in California. On the left is the ZBest facility, and that's in Gilroy, and primarily processing the uh, organic residuals from city of San Jose. And on the right is the Inland Empire compost pond that's completely, so on the left it's an outdoor system. On the right is a completely enclosed indoor system that actually was an IKEA warehouse, distribution warehouse that was refurbished. Those are solar panels on top. They now have a wind turbine in addition to it. And so very aggressive, very expensive composting system. And the one exception to the rule that these same four uh, parameters have to maintain the other scale. The exception to that rule would be vermicomposting. I'm not going to talk about vermicomposting today. Danny will a little bit at the end, but I do want to recognize it as an excellent technique because you're dealing with larger organisms, worms versus microbes. They are more sensitive to the conditions. They will leave if things go wrong, whereas the microbes will stay there. But worms have the great ability that under the right conditions can actually eat half their weight every day. And so imagine, if you weigh 200 pounds, you'd be eating 100 pounds a day and not gaining weight. And these worms, if there's 20 pounds of worms in that bin, they could be eating 10 pounds every day. Enough on vermicomposting for me. So I just want to conclude with a couple comments about why we're bothering at all. What's the advantages of composting, and going to cover three of them. First, I'm going to talk about biosecurity. So biosecurity means that composting helps prevent spread of various things. It helps prevent spread of disease, human diseases, plant diseases, or invasive species. Uh, you may have heard or remember the situation where a few years ago where spinach there was a 017H, there was a bacterial E. coli contamination in spinach and caused millions of dollars of damage and actually killed several people. At first, compost was blamed for that because the spinach grower had spread compost on his fields. In the end, though, compost was the only thing that was definitely eliminated as a cause. And now the growers of these leafy greens, if they want to add organic matter to their soil, it has to be composted first. And so it's recognizing that composting kills disease pathogens. It helps protect us from those. Another really important feature of composting is landfill diversion. So keeping organics out of landfills, first of all, it saves the camp money because instead of paying for disposal, you're managing it on site. Second, it benefits the landfills, it benefits us as a society because landfills are expensive, they're hard to site, and so the more we keep stuff out, the longer they last. And really important is that organics going into landfills are the cause of methane, that is a powerful greenhouse gas. Organics themselves do not have methane. It's only when they break down under the anaerobic conditions, like in a landfill, that methane is created, and some of it will always escape, and that's a powerful greenhouse gas. So by keeping organics out of landfills, we are helping to reduce global climate change, or greenhouse gases that lead to climate change. And just to wrap up here on the benefits of compost use, to why we're making going through all this trouble ultimately is to make compost. Compost has tons of benefits. I don't have time to go into that today, but it helps our soils be more healthy by increasing their life. It helps the plants that grow in those soils be more healthy. It helps us with our water management because soils with increased organic matter can accept water faster, preventing runoff and pollution, hold water longer, so it helps address drought issues. And then finally, compost, some of that compost, and we're learning more and more about some of that, how that compost can be permanently stored in the soils and help sequester carbon, again, addressing climate change. So I've gone a little bit over my time period. I apologize for that. But thanks for your attention. This is my final slide here, composting at a camp in Texas. I just like the way they kind of laid out their instructions right there in front of the compost bins. So with that, I will turn it back over to Danny.
Awesome. Thank you very much, Carrie. We greatly appreciate your participation today. Some wonderful information as well. And we see that, there's a lot of information to take in when it comes to composting. And, one of the mottos or the things that I say a lot at Green Camps Initiative is that there's not one model of sustainability that's going to work for every camp. And so the first step is to really educate ourselves and understand how each camp can function and what those